Welcome to Dr. Ishinaria's Deep Dish Dialogues. Today we're embarking on an absolutely epic journey, really a deep dive into a topic that spans billions of years. And it asks some truly profound questions about our planet's sprawling history and, well, the incredible nature of ancient stories. This is the deep dive, where we take your curiosity, your sources, and we unearth the most important, often surprising nuggets of knowledge that help you feel truly well-informed. Our mission for you today is to meticulously unpack the scientific timeline of Earth. We'll trace its path from a fiery, molten birth all the way to the comparatively recent rise of humanity. And then we're going to bravely explore how ancient narratives, specifically the timeless Indian epics of the Ramayana and Mahabharata, might or might not fit into this grand scientific picture. You, our curious listener, brought us a truly fascinating, almost mind-bending question. Could these epic events, with their tales of advanced weaponry and powerful beings, could they have actually occurred before one of Earth's great mass extinctions? It's a question that beautifully bridges the rigorous world of science, the rich tapestry of mythology, and that deep human curiosity that compels us, I think, to connect the dots across time.
It's an excellent question, really a truly provocative one that forces us to think critically about different forms of knowledge, different ways of understanding. We'll be synthesizing a vast amount of information. We're looking at the cold, hard data of geological records, the silent whispers of fossil evidence, and the intricate logic of modern scientific interpretations. Then we'll contrast all of that with the vibrant, deeply meaningful, yet often symbolic tapestry of mythological narratives. This is a journey through deep time, yes, but also through the even deeper, boundless expanse of human imagination.
Okay, let's unpack this. Buckle up. It's going to be quite a ride. 1. Earth's grand timeline, a scientific overview. So when we talk about Earth's history, the very first thing that hits you, that really slams you, is just the sheer, almost incomprehensible scale of time. We're not talking centuries or millennia here. We're talking about something immense, a timeline stretching back roughly 4.54 billion years. So that number is so vast, it's practically impossible for our brains to truly grasp. It makes 1,000 years feel like just a heartbeat.
It really does put things into perspective. And, to underline just how vast that number is, let's try an analogy just to help us feel it, not just hear it. Imagine Earth's entire 4.54 billion year history condensed into a single 24-hour day. Okay, so Earth forms at midnight. The first life wouldn't even appear until maybe 4 a.m.
4 in the morning, wow.
Yeah, and dinosaurs, they burst onto the scene around 10:30 p.m., but they'd be gone by 11:04 p.m.
Gone before midnight.
Exactly. And for us, Homo sapiens, anatomically modern humans, we wouldn't show up until the last mere fraction of a second before midnight strikes again.
A fraction of a second.
That's the mind-blowing insight here. Our entire human story, from our earliest ancestors to, our bustling cities today, occupies this infinitesimally small fraction of Earth's total existence. Modern humans, we've only been around for about 300,000 years, which, as you said, mathematically, it's roughly 0.004% of Earth's entire history. This perspective isn't just interesting, it's absolutely crucial as we delve into this question of ancient stories in deep time, because it highlights just how astonishingly recent our presence is. We are, geologically speaking, brand new.
It's incredible. It makes you feel incredibly small, doesn't it?
Yeah.
So the big question then is, how do we even know all this? It feels almost impossible reconstructing something so far back across billions of years. What are the ingenious methods scientists use to piece this vast puzzle together to arrive at such specific numbers?
Right. It's not magic, but sometimes it feels close. It's a combination of incredibly meticulous, powerful scientific methods. When you weave them together, they create a remarkably robust, consistent picture of the past. Primarily, we rely on fossil records and geological evidence. Think of Earth itself as this giant history book, right? Written in layers of rock. We study actual skeletons, incredibly detailed imprints left by ancient organisms, even subtle chemical signatures embedded within different rock layers. That's a field called stratigraphy.
Okay.
Each layer of rock, laid down over millions of years, tells a unique story about the environment, the climate, the life forms present when it formed. We're literally reading Earth's autobiography.
And the dates. How do we know how old those pages are?
That's where radiometric dating comes in. It's truly revolutionary. This involves measuring the predictable decay of radioactive isotopes like uranium-238 or carbon-14 within rocks and fossils. Because these isotopes decay at a known constant rate, it's like a tiny geological stopwatch. Scientists can determine very precise, almost shockingly accurate ages for the materials. This technique gives us those precise billion-year figures for Earth's age, the timing of major events. It's an independent line of evidence that consistently confirms what we see in the rock layers. And beyond that, we have ice cores and sediments. Extracted from deep beneath ancient ice sheets or ocean floors, they provide incredibly valuable proxy data.
How so?
Well, they trap ancient air bubbles, dust, pollen, volcanic ash from past atmospheres. They reveal ancient climates, atmospheric composition, even direct evidence of past volcanic eruptions or global extinctions. Then there's DNA analysis. This lets us trace the evolutionary pathways, the branching of life forms with incredible precision, shows us how species are related, when they diverged, even ancient migrations.
Amazing.
And geochemistry analyzes subtle isotopes, other chemical signatures in rocks to infer past climates, oceanic conditions, even the presence of ancient life. Finally, paleoclimatology uses various data like tree rings, coral growth, even historical documents to reconstruct past climates. Helps us understand past environmental shifts. It's a testament to human ingenuity, really.
So we have all these powerful cross-referencing tools giving us this incredibly detailed picture. But is it perfectly complete, like a fully painted masterpiece? Or are there still some blank spots, some gaps, especially when we're talking about periods so unimaginably far back?
That's a very important point, a very insightful one. While the broad strokes of Earth's history are remarkably well established, supported by multiple independent lines of evidence, meaning different methods consistently point to the same conclusions, it's absolutely essential to acknowledge that gaps exist. Areas of ongoing research are definitely there. For instance, Precambrian records, that's the vast expanse of time before about 541 million years ago, representing, the first 88% of Earth's history. They're notably sparser.
Why is that?
Well, largely because the earliest life forms were often microscopic, soft-bodied organisms. They just don't fossilize well. Imagine trying to find the fossil of a jellyfish.
Right, not easy.
Plus, Earth is a dynamic planet. It's constantly recycling its crust through plate tectonics, subduction, erosion. These processes can deform, melt, or destroy ancient geological evidence over immense timescales. Similarly, reconstructing pre-extinction ecosystems perfectly can be challenging. Mass extinctions leave clear boundaries, yes, like the iridium layer at the KPG boundary, but the detailed picture of life right before these cataclysms, down to the last species, that can be harder to get due to those same geological processes.
Makes sense.
And when we talk about humanity, while archaeological records are incredibly robust for the last, say, 10,000 to 20,000 years, early human and pre-human evidence becomes much more fragmented, much rarer compared to recent findings. It's like finding a few scattered puzzle pieces from the very beginning of a massive, complex puzzle. Many pieces are clear, but some are still being discovered or inferred or maybe just lost to time. We always aim for more knowledge, but we work with what the Earth has preserved.
That makes perfect sense. A scientific detective story spanning billions of years. So let's go back to the very beginning, to Earth's immense timeline. Let's walk through the different eons, really set the scene, starting with the Hadean eon. Just the name sounds, well, hellish. A chaotic beginning.
It absolutely earns that name. The Hadean eon, spanning from Earth's formation around 4.54 billion years ago to about 4.0 billion years ago. It was a time of unimaginable violence, extreme heat, constant transformation. Picture this: Earth forming from a swirling cloud of cosmic dust and gas left over from the sun's birth. Gravity pulls this material together. It accretes into a superheated, molten ball.
Literally molten.
Literally molten. Its surface was a vast global ocean of magma glowing with intense heat. This period also saw the late heavy bombardment. Earth was relentlessly pummeled by asteroids and comets, huge craters, more heat, more material. It's also during this time, likely around 4.5 billion years ago, that our moon formed. A truly cataclysmic event. A massive object, maybe Mars-sized, collided with the young Earth, tearing off a huge chunk that eventually became our moon. The early atmosphere. Incredibly toxic. A dense soup of methane, ammonia, carbon dioxide, sulfur compounds, utterly inhospitable to life as we know it. But gradually, painstakingly, the planet began to cool. Evidence from ancient zircon crystals, the oldest known minerals, suggests liquid water. Oceans began forming as early as 4.4 billion years ago. Astounding given the conditions.
Wow.
Still, no life known during this fiery beginning.
So the planet eventually cools enough for oceans to form, and we move into the Archean eon. What's happening then? Is this where life finally starts to stir?
Precisely. The Archean eon, running from 4.0 to 2.5 billion years ago, marks a truly crucial turning point. The planet began to stabilize significantly. The remaining molten rocks solidified, forming Earth's first stable, though still thin, crust. This allowed for continuous oceans, and crucially, the first continents began to emerge. Much smaller, more numerous than today, but they were there. And yes, most significantly, this is when life, in its most primitive form, finally emerged. Simple, single-celled organisms, prokaryotes, tiny cells without a nucleus, appeared around 3.8 to 3.5 billion years ago.
So,
The earliest clear biological structures we find, direct evidence of this life, are stromatolites. Layered, mound-like formations built by microbial mats, often cyanobacteria, in shallow water. Basically, ancient microbial apartment complexes. These early photosynthetic bacteria were incredibly important. They were starting the slow, monumental process of changing Earth's atmosphere, though it was still largely oxygen-poor back then.
and here's where it gets really interesting for life as we know it.
Yeah.
Oxygen. That brings us to the Proterozoic eon. This sounds like a period of immense change.
You're absolutely right. The Proterozoic eon, lasting from 2.5 billion years ago to 541 million years ago, was a period of profound environmental and biological transformation. It arguably set the stage for everything that followed. The most significant event, the Great Oxygenation Event, around 2.4 billion years ago. Driven by those photosynthetic cyanobacteria we just mentioned, they got really good at harvesting sunlight and, as a byproduct, pumped vast amounts of free oxygen into the oceans, then the atmosphere.
And that changed everything.
Fundamentally, it changed Earth's chemistry and, in a fascinating twist, caused the first major mass extinction. It wiped out many anaerobic organisms that thrived in the oxygen-free environment. For them, oxygen was poison.
Wow, life-causing extinction.
Exactly. But for others, it paved the way for more complex life. We see the crucial evolution of the first eukaryotic cells, those with a nucleus, more complex structures around 1.8 billion years ago. This innovation was a prerequisite for multicellularity, which emerged with the first truly multicellular life forms around 1.2 billion years ago, growing larger, more diverse. This eon also saw several dramatic snowball Earth periods, the planet almost entirely covered in ice, extreme conditions that pushed life to adapt and evolve.
And then, finally, after all those billions of years of microbial life, single cells, simple multi-celled organisms, we reach the Phanerozoic eon. That's the current one, right?
Yeah.
One where life becomes truly visible and complex.
That's right. The Phanerozoic eon, stretching from 541 million years ago to the present, is often called the era of visible life, because it's characterized by the incredibly rapid diversification and proliferation of complex life forms we can easily recognize in the fossil record. This is when large, complex animals and plants explode onto the scene, leading us into the eras where life, as we understand it, truly began to flourish and evolve into the myriad forms we see today. It's the period of Earth's history most thoroughly documented by fossils, making it easier for us to trace the lineage of life right up to our present moment. 2. The Phanerozoic eon, eras of complex life and cataclysm.
So, within this Phanerozoic eon, which is still pretty brief in the grand scheme of things, we have distinct eras. The Paleozoic era, for instance, starts with something called the Cambrian explosion. That sounds incredibly dramatic, like the Big Bang for animal life.
It absolutely was dramatic, truly an evolutionary fireworks display. The Paleozoic era, spanning from 541 to 252 million years ago, began with the Cambrian explosion, roughly 541 to 530 million years ago. This wasn't just slow diversification, it was a period of astonishingly rapid appearance where most major animal groups, including iconic creatures like trilobites, early arthropods, the very first fish-like vertebrates, suddenly appear in the fossil record.
Suddenly.
Well, geologically suddenly. An explosion of novel body plans, marine life, a foundational moment for all animal evolution. This era then continued with other key developments. The Ordovician period saw marine life flourish even further. Profusion of invertebrates, first-jawed fish appear. In the Silurian period, around 450 million years ago, plants took a monumental leap, colonizing land for the first time, quickly followed by the first land animals, mainly arthropods like early spiders, centipedes.
Life comes ashore.
Yes. Then the Devonian period, often called the Age of Fish. Spectacular rise of diverse fish species, including lobe-finned fish that would eventually give rise to land vertebrates. Importantly, this period also saw the first amphibians, making the leap onto land, and the development of vast forests. The Carboniferous period followed, characterized by immense swampy forests. These eventually formed the massive coal deposits we rely on today. It also saw the evolution of the first reptiles, fully terrestrial, no longer tied to water for reproduction.
Okay.
Finally, the Permian period marked the dominance of these early reptiles and mammal-like reptiles, setting the stage for what came next. This entire era, however, concluded with the most severe mass extinction event in Earth's history. A true reset button we need to discuss.
Then we move into the Mesozoic era. This is the one everyone knows, the one that captures the imagination, the age of reptiles, the reign of the dinosaurs.
Indeed, the Mesozoic era, from 252 to 66 million years ago, is undeniably the age of reptiles. Dinosaurs ruled supreme for a staggering 186 million years. It's divided into three periods. The Triassic period saw Earth recovering from that devastating Permian extinction, a time of new beginnings where the first dinosaurs and primitive, shrew-like mammals made their hesitant appearance. Then the iconic Jurassic period, where dinosaurs truly dominated the land, growing to immense sizes, Stegosaurus, Brachiosaurus roaming vast landscapes. This period also saw a remarkable leap. The first birds evolved directly from theropod dinosaurs.
Birds are dinosaurs.
Technically, yes. Avian dinosaurs survived. Then the Cretaceous period brought flowering plants, angiosperms, which fundamentally changed ecosystems, new food sources, habitats. This was also a time of vast dinosaur diversity, T-Rex, Triceratops. This era, of course, famously ended with the cataclysmic extinction that wiped out the non-avian dinosaurs, a momentous event that completely reshaped the planet's trajectory.
And that brings us to the Cenozoic era, our current era, the age of mammals. This is where our story, our direct lineage, truly begins to take shape.
Precisely. The Cenozoic era, from 66 million years ago to the present, is truly the age of mammals. After the dinosaurs' dramatic extinction, a massive ecological void was left. Mammals, which had been small, inconspicuous under the dinosaur shadow, suddenly had the opportunity. They diversified rapidly, radiating into every imaginable ecological niche that was vacated.
Filling the gap.
Exactly. They evolved to fill roles previously held by dinosaurs, growing in size, complexity, specialized forms from bats in the air to whales conquering the oceans. Early primates, our distant ancestors, appeared around 55 million years ago, cautiously navigating forests. This era saw the evolution of all modern mammal groups we recognize: whales, horses, elephants. It also saw the significant expansion of grasslands, driven by changing climates which spurred the evolution of grazing animals. This era includes the Quaternary period, characterized by cycles of massive ice ages, dramatic climate flex, and, most profoundly for our discussion, the incredibly recent rapid rise of humans, leading us right up to today. 3. Earth's reset buttons, the 5 major mass extinctions. As we've journeyed through this immense geological timeline, it becomes strikingly clear that life hasn't progressed smoothly, not in an uninterrupted line. Instead, it's been punctuated by periods of cataclysmic change, what we call mass extinctions. These aren't just minor dips, these are periods where a truly significant percentage of species, often 75% or more, sometimes over 90%, disappear from the fossil record in a relatively short geological time frame.
Earth's reset buttons.
Exactly. They fundamentally reshape the course of evolution, clearing the way for new life forms to emerge and diversify. A key point here, especially for your listener's question, is that scientists can, with remarkable accuracy, reconstruct what life was like before these events. By studying fossils and geological evidence, the abrupt changes in fossil assemblages at specific rock layers clearly indicate these dramatic shifts, like a sudden blank page in Earth's history book before a whole new chapter begins.
And there have been 5 major ones, right? The big 5 that truly reshaped life on Earth. It's fascinating, this cycle of catastrophe and renewal.
That's correct. These are often called Earth's reset buttons because they dramatically reshape evolution's course, clearing the way for new life. Each one is a story of incredible loss, followed by equally incredible recovery. First, the Endordovian extinction, around 444 million years ago, saw about 85% of all marine species vanish, likely due to severe global glaciation, locking up water and ice sheets, causing sea levels to drop dramatically, changing climate, widespread habitat loss. Okay. Next, the late Devonian extinction, around 375 million years ago, wiped out about 75% of all species, particularly marine life. The exact cause is still debated, but leading theories include prolonged global climate change, maybe cooling, and widespread anoxia, a severe lack of oxygen in the oceans, perhaps triggered by the rapid expansion of land plants, altering nutrient cycles.
Complex.
Then the infamous End-Permian extinction, around 252 million years ago, known as the Great Dying, by far the most severe, a true biological apocalypse. It catastrophically eliminated an estimated 96% of marine species and 70% of terrestrial vertebrates.
96%. Unbelievable. Unbelievable.
The most widely accepted cause: massive, sustained volcanic eruptions in the Siberian traps. These released enormous amounts of greenhouse gases, leading to rapid global warming, widespread ocean acidification, severe anoxia, a truly hellish environment. It took tens of millions of years for life to truly recover. The fourth was the end Triassic extinction, around 201 million years ago. Saw about 80% of species lost. Also strongly linked to intense volcanic activity, this time associated with the breakup of the supercontinent Pangaea and rapid climate change. Critically, this cleared the way for dinosaurs to become dominant in the subsequent Jurassic period. One group's loss, another's opportunity.
Right.
And finally, the most famous one, the end Cretaceous extinction, about 66 million years ago, the cataclysmic event that famously wiped out the non-avian dinosaurs, along with around 75–76% of all species. The primary cause, yes, the impact of a massive asteroid forming the Chicxulub crater in Mexico triggered widespread tsunamis, massive wildfires, ejected an immense dust cloud blocking the sun, leading to a global winter. This impact was likely exacerbated by significant volcanic activity in India. The Deccan traps also contributing to climate shifts and environmental stress.
So after hearing about these 5 cataclysms, these reset buttons, what does this all mean for us today? Are we right now facing another one? It's a sobering thought.
It's a very pertinent and indeed sobering question, and one many scientists are actively researching and debating. Many respected scientists argue that, yes, we are currently in the midst of what could be considered a 6th mass extinction event. Unlike the previous 5, driven largely by natural, geological, or astronomical phenomena, this current event is overwhelmingly, undeniably driven by human activities.
Our fault.
Largely, yes. Factors like rampant habitat destruction, accelerating climate change from greenhouse gas emissions, widespread pollution, overexploitation of natural resources. They're leading to an alarming rate of species loss globally. Some estimates suggest we could lose around 1 million species in the coming decades, a rate far exceeding the natural background extinction rate. It underscores the profound, unprecedented impact humanity is having, our immense power, and our responsibility. 4. Humanity's fleeting moment. Evolution and civilization. Given the immense vastness of Earth's history we've just covered, it's worth reiterating, really focusing on a crucial point. The entire story of human evolution is incredibly recent, almost ephemeral. It spans roughly the last 7 million years in the grand geological narrative, a mere blink compared to the eons of microbial life or the reign of dinosaurs. Our journey begins with the divergence of our lineage from chimpanzees, our closest living relatives. The earliest known hominin, Sahelanthropus chidensis, appeared around 7 to 6 million years ago, marking the initial steps away from a common ancestor. Following this, species like Australopithecus emerged between 4 and 2 million years ago. This is the genus Lucy belongs to. Critically, this is when upright walking bipedalism truly began developing as a defining human characteristic.
Taking those first steps, literally.
Literally. Around 2.5 million years ago, we see the first definitive evidence of stone tools. Very simple but effective Oldowan tools, the dawn of technology. This period also saw Homo habilis emerge around 2 million years ago, often credited with more sophisticated tool use, perhaps early steps towards language. Then, approximately 1.8 million years ago, Homo erectus appeared. A pivotal species, the first hominin to leave Africa, spread across vast parts of Asia and Europe, showing remarkable adaptability.
And then us, Homo sapiens, and the dawn of what we recognize as civilization. How recent is that, really, in the grand scheme? It feels like we've been around forever, but you're saying that's just not the case.
You're right. Our perception of time is so skewed by our own lifespan. Our own species, anatomically modern Homo sapiens, evolved in Africa much more recently than many people realize, around 300,000 years ago. And for a very long period after that, Homo sapiens lived as nomadic hunter-gatherers, masters of their environment, sure, but without permanent settlements or complex societal structures. Then came what some call the cognitive revolution, roughly 70,000 to 50,000 years ago. This marked a profound leap. Development of complex language, abstract thought, symbolic art, modern human behavior.
Thinking differently.
Exactly, allowing unprecedented cooperation, creation of elaborate cultures, transmitting complex knowledge across generations. The true turning point for organized sedentary society was around 12,000 years ago, the agricultural revolution. Not just a discovery, a fundamental shift from nomadic life to settled farming. Cultivating crops, domesticating animals. Right. Allowing surplus food, leading directly to permanent settlements, villages, feeding much larger, denser populations. This laid the groundwork for the first true cities and kingdoms. Writing systems, a monumental leap, emerged around 5,000 years ago. Sumerian cuneiform, Indus Valley script. This era then saw the rapid rise of major ancient civilizations. Sumer, ancient Egypt, the sophisticated Indus Valley civilization, early Chinese dynasties, later Greece and Rome, leading us into historical periods with detailed written records, culminating in our complex modern era. It's an explosion of human ingenuity, but incredibly, incredibly recent in Earth's deep time. 5. The intersection of science and story, Ramayana, Mahabharata, and deep time.
Now, connecting all this incredible scientific history, all these eons, eras, molten Earth, to human civilization back to your original, truly thought-provoking question.
Yeah.
What about stories like the Ramayana and Mahabharata? Could they have actually happened before a mass extinction event? It's a truly intriguing thought, blending the cold, hard facts of science with the rich, vibrant world of ancient narratives.
It is a captivating question, and it beautifully illustrates how human curiosity tries to bridge seemingly disparate fields of knowledge. However, to approach it rigorously, it's crucial to delineate clearly between scientific understanding relying on empirical evidence, testable hypotheses, and mythological narratives, which often serve different cultural, spiritual purposes. From a scientific perspective, it's fundamental to understand that the Ramayana and Mahabharata are categorized as epic, mythological, and historical literary texts. Scholars, using extensive cultural, linguistic, literary, some archaeological analysis, typically date the composition of the Ramayana to roughly 1500 to 500 BCE, and the Mahabharata to around 1400 BCE.
So thousands of years ago, not millions.
Precisely. While these texts clearly draw upon much older oral traditions, maybe predating the written versions, their stories and characters are firmly rooted within the human historical timeframe, not geological deep time. The fundamental scientific position on your question is unequivocal. There is no reliable scientific evidence. None. From geology, archaeology, paleontology, any empirical field to support the idea that the events described in these epics occurred before any of Earth's previous major mass extinctions. This isn't dismissing their cultural importance, not at all. It's merely an assessment based on scientific methodology.
Why is that the case, though? What makes a pre-extinction occurrence of such events with their grand characters, maybe advanced technology, so highly improbable scientifically? If there were flying vehicles, powerful weapons, why couldn't that have been millions of years ago?
There are several compelling, really irrefutable reasons rooted in the scientific record that make such a scenario extremely improbable, bordering on impossible, scientifically speaking. First, consider the sheer overwhelming timeline mismatch. The last major mass extinction, the Cretaceous-Paleogene one that wiped out the non-avian dinosaurs, occurred 66 million years ago. As we just discussed, Homo sapiens, anatomically modern humans, the species depicted as the central characters in these epics, only evolved around 300,000 years ago.
A huge gap.
A 65 million year gap. Our species came into existence long after the last the epics, thousands of years ago, are vastly, almost incomprehensibly different from geological deep time, which operates in millions or billions of years. Second, there's the critical issue of evolutionary impossibility. The central characters in both epics are clearly depicted as modern humans. They walk upright, have complex societies, use advanced language, engage in intricate moral reasoning, develop technology. Their motivations are distinctly human inheritance, duty, love, revenge, justice. Our species, Homo sapiens, simply did not exist prior to the last mass extinction, let alone earlier ones like the Great Dying 252 million years ago. During the age of dinosaurs, the dominant land animals were dinosaurs, not human civilizations engaging in complex warfare. The very biology and sociology are a fundamental mismatch.
But even if they weren't Homo sapiens, exactly as we know them, if an advanced civilization, even one with fantastic elements like flying machines or superweapons, existed that long ago, say, before the dinosaurs died out, wouldn't we find something? Some kind of undeniable physical trace?
Exactly. This leads to the third, perhaps most compelling scientific argument: the pervasive lack of archaeological and geological evidence. If a highly advanced human or human-like civilization existed millions of years ago, we would expect to find substantial, undeniable physical traces.
Like what?
Durable materials, advanced tools, large quantities of processed metals, maybe long-lasting plastic residues or other synthetics, remnants of extensive architecture, widespread fossil remains of such a species, perhaps even a distinct technofossil signature across rock layers. Yet, despite extensive geological and paleontological research across the globe, probing every continent, every ocean floor, none of these traces have been found dating from before the Holocene epoch, which began just 12,000 years ago. What we find before that are very primitive stone tools and then increasingly ancient non-human life forms. Now, it's true, Earth is dynamic. Plate tectonics, erosion, subduction where one plate slides under another, melting rock over immense timescales. These processes can certainly obliterate some evidence.
Not all evidence.
Highly unlikely. These processes probably wouldn't destroy all global evidence, especially of durable, widely dispersed materials from a planet-spanning technologically advanced civilization. The complete and utter absence of such evidence across the vast geological record before the Holocene is, scientifically speaking, incredibly telling. It's not just a missing puzzle piece, it's an entire missing continent of evidence, if you will. So, to offer an initial firm scientific conclusion, while the idea that the Ramayana and Mahabharata could have occurred before a mass extinction is a wonderfully creative, fascinating, speculative idea, there's currently no scientific evidence whatsoever to support the existence of advanced human civilizations or complex societies during or before any known mass extinction events. Our scientific understanding of Earth's history, particularly human evolution, simply doesn't align with that possibility. The evidence places human civilization firmly in the last few thousand years. 6. Deep dive into interpretations beyond literal history.
Okay, so since a literal historical reading for these epics, especially placing them in deep time, just doesn't line up with the massive scientific evidence, how should we interpret them? This is where it gets really interesting, right? Moving beyond simple history into meaning, metaphor. You've touched on some fascinating alternative theories that let us appreciate their enduring power.
Exactly. This is where their true depth and relevance emerge. If they're not literal historical accounts from the deep past, then their profound power, their ability to resonate for millennia, must come from something else entirely. We can explore two compelling frameworks for interpretation, both widely respected by scholars, philosophers, spiritual traditions. Let's dive into theory 1. Ancient science fiction speculative allegory.
The idea of them being ancient science fiction sounds captivating. Your Jetsons principle analogy is great. Can you explain that again? How modern sci-fi like the Jetsons with flying cars, video calls, how it extrapolates from present trends, and how that applies here.
It's a perfect analogy, I think. Modern sci-fi, the Jetsons, Star Trek. It doesn't predict the future because the creators have mystical foresight. Not at all. Instead, they operate on a very human principle. They look at current tech trends, inherent human desires, wishing to fly, communicate instantly, have abundant food, and current societal challenges. And then they ask, what if? They
See a phone, imagine a video call.
Precisely. See a car, imagine a flying car. See a cannon, imagine a superweapon. In the same vein, ancient texts, including the Ramayana and Mahabharata, can be seen operating on a similar speculative principle. Their authors, working within their time's knowledge, imagine things like flying vehicles, Vimanas, magical servants, weapons with extraordinary power like the Brahmastra, divine communication across distances, magical sustenance. These elements represent incredibly creative, imaginative extrapolations from contemporary capabilities and, crucially, fundamental human desires for power, speed, communication, control over nature. The irony is, what has come true today, video calls, flying across continents, powerful weapons, isn't a literal prediction from the story. It's the underlying human desire for such capabilities, that yearning to transcend limits, realized through the scientific method, engineering, accumulated knowledge. The texts capture the aspiration, not the blueprint.
But the epics mentioned very real places, right? Places still existing today. Himalayas, Ganges, Kurukshetra. Doesn't that heavily imply they are historical accounts, at least in setting? That's the geographic anchor effect.
Absolutely. That's the geographic anchor effect, a very common, incredibly effective literary technique. Verisimilitude, the appearance of being true or real. Authors ground fantastic stories in real, familiar geography to make them more believable, immersive, relatable. Think about it. Sherlock Holmes at Baker Street, Harry Potter at King's Cross.
Right. Real places make the fiction feel closer.
Exactly. That grounding makes the leap into magic, mystery, fantastical battles far more compelling. The real places in the epics, the sacred Ganges, towering Himalayas, Kurukshetra, plain lend authenticity, cultural resonance. They make the story feel immediate, relevant. But they absolutely do not validate the supernatural or fantastical elements as literal history. It's a masterful storytelling device, drawing you in, making the story world tangible, not an archaeological map. The purpose is narrative immersion, not historical recording.
And what about those fascinating, sometimes controversial comparisons people make? relating the miraculous birth of the 100 Kauravas to modern IVF or cloning, or suggesting the Brahmastra was an ancient nuclear device. That sounds exactly like the retrofitting problem you mentioned.
That is a crucial logical fallacy, a pervasive cognitive trap. Retrospective fitting, or the retrofitting problem, is when we take modern scientific knowledge, which took thousands of years of observation, experimentation, accumulated data, and project it onto vague, metaphorical, miraculous ancient stories, trying to find precise parallels where none truly exist. For example, the Kauravas' birth story. Gandhari's pregnancy results in a lump of flesh, divided into 100 parts, incubated in jars of ghee, developing into children. A modern mind might jump to IVF or cloning.
You can see why they might make the link.
You can see the superficial resemblance, yes. But the ancient story utterly lacks any scientific detail. No mention of sterile environments, genetic manipulation, hormones, cell division, sophisticated biology. It's depicted as miraculous, divine, unnatural, not a scientific blueprint or medical procedure description. Same applies to the Brahmastra. Described as incredibly destructive, yes. Causing devastation, long-term barrenness. But the epics describe its effects in mythological terms: divine power, cosmic forces, not with scientific explanation of nuclear fission, radiation, specific mechanics. The fact that a theme or concept resembles modern science doesn't imply the ancients possessed that specific knowledge. It's superficial correlation, not causation. Often, it's wishful thinking, trying to make ancient texts seem ahead of their time, but it overlooks the very different ways of knowing at play. They weren't writing science manuals, they were writing moral epics. This leads to another important question. If these texts contained actual advanced knowledge, described forgotten high-tech civilizations, why aren't they presented with scientific accuracy? Why no precise specs, blueprints, consistent principles?
Your Hollywood analogy here is perfect. It really drives the point home.
Right. If these were genuine records of advanced knowledge, we'd expect what any engineer looks for: precise technical specs, accurate scientific principles, detailed manufacturing processes, clear instructions. Instead, we find vague metaphorical descriptions, inconsistent rules for how things work, heavy emphasis on magical or divine explanations. The purpose was profoundly different: to inspire, moralize, symbolize profound truths, entertain, not instruct in engineering or physics. Just as future generations won't look at Star Wars and conclude George Lucas had mystical knowledge of the Force or that warp speed is real, ancient authors were creative people working with their time's knowledge and desires, envisioning better worlds, extraordinary capabilities, profound challenges through imagination. This perspective, I think, makes the texts even more impressive as enduring works of human creativity, philosophy, insight, rather than limiting them to flawed scientific documents. Now let's explore Theory 2, allegorical blueprint for humanity universal situations. The second theory offers a profoundly rich, widely respected interpretation, accepted by numerous scholars, philosophers, spiritual leaders across centuries. This view posits these epics aren't literal history, nor just ancient sci-fi. Rather, they serve as profound allegories about the human condition, timeless moral lessons, speculative visions of human potential that transcend any single historical period. Their enduring power, universal resonance, lies precisely in exploring universal themes and archetypes. They delve into fundamental human struggles just as relevant today: duty, dharma versus desire, justice versus injustice, the realities of war, the quest for peace, intricate family dynamics, loyalty, temptation, honor, fate, free will.
All the big questions.
All the big ones. The Mahabharata's Kurukshetra war, for instance, is often interpreted not just as a physical battle, but as a powerful allegory for the inner struggle within every human. Virtue versus vice, self-interest versus righteousness, light versus shadow within the soul. Similarly, the Ramayana is often seen as the soul's journey. Rama embodying ideal righteousness, sacrifice, leadership; Ravana representing ego, unchecked power, destructive attachments. The characters themselves are timeless archetypes: Rama as ideal king, Sita as purity and resilience, Ravana as destructive ego, Arjuna as the conflicted soul facing moral choice, Krishna as divine guide, inner conscience, wisdom. They resonate across cultures and time because they reflect fundamental aspects of our shared humanity, universal experiences, deepest moral dilemmas.
So in that sense, they could be seen as a blueprint for future challenges, not predicting events, but a guide, a map for navigating what might come no matter the era. That's incredibly powerful.
Exactly. This is where their wisdom truly becomes a blueprint, not a literal forecast, but a timeless ethical and psychological guide. These epics serve as remarkably insightful cautionary tales, profound guides for navigating complex situations, even those far removed from their original context. They reflect timeless human situations that repeat. Political intrigue, family conflicts, leadership dilemmas, moral consequences of power, especially unchecked power. They anticipate recurring challenges, like the moral implications of technological advancement perhaps echoed in the dilemmas around the Brahmastra, or the cyclical nature of civilization's rise and fall, the inevitable corruption of power. In essence, they're not just stories, they're a sophisticated map for navigating complex ethical, political, existential situations. These allegories remain remarkably applicable today, even to hypothetical future contexts like space colonization, new societies on other planets, AI ethics. They show us the perennial human struggles, regardless of tech. Their enduring power lies precisely here. These stories survived millennia, cherished by millions, not because they recount a specific forgotten battle or past tech marvel, but because they hold a reflective mirror to the human soul. They provide a rich framework for ethical action, a source of profound wisdom, a space for exploring existence itself, just as potent today as thousands of years ago. They become not merely records of what was, but deep, multi-layered maps of what could be individually in our moral lives, collectively as societies navigating an ever-changing world. That's their true magic. 7. The extraterrestrial hypothesis, a theoretical exploration.
Okay, so if it didn't happen on Earth as literal history in deep time, and we're looking at these epics as maybe profound ancient science fiction or an allegorical blueprint,
Okay.
what about the idea that these events could have occurred on another planet and that the stories somehow impossibly reached Earth? That's a truly captivating, though undeniably unproven idea that often pops up in popular culture, isn't it?
It is indeed a fascinating premise, one explored extensively in speculative sci-fi and ancient astronaut theories. From a purely theoretical standpoint, this hypothesis tries to address the complete absence of Earth-based evidence for ancient advanced civilizations by simply positing the events happened elsewhere, in a galaxy far, far away, perhaps. Within this framework, fantastical elements get reinterpreted technologically. Vimanas as advanced spacecraft, Astras as powerful energy weapons of a highly developed alien civilization. Even gods could be seen as members of this advanced alien race, interacting with less developed populations, maybe on another world, or maybe fleetingly on early Earth. It certainly makes for a compelling narrative.
That definitely sounds like a plot for a blockbuster movie,
Yeah.
a true cosmic saga. But what are the significant scientific and logical problems with this theory? Because, on the surface, it almost neatly sidesteps the lack of Earth-based evidence.
While captivating, this hypothesis faces significant, almost insurmountable hurdles, logically and scientifically. The most profound problem is the deeply and profoundly terrestrial context of these epics. The Ramayana and Mahabharata are intricately, specifically rooted in the geography, ecology, culture of the Indian subcontinent. They mention specific Earth-native rivers, Ganges, Yamuna, identifiable mountains, Himalayas, instantly recognizable animals, elephants, tigers, bears, monkeys, distinct plants, banyan tree, ashoka tree.
Right, very Earth-specific.
Incredibly so. One must seriously ask, why would a historical account from another planet feature such incredibly specific earthbound details? Down to the flora and fauna of a particular region on our world, it strains credulity beyond breaking point. Furthermore, the anthropocentric nature of the narratives is striking. The characters, motivations, societal structures, dilemmas are fundamentally human. They grapple with quintessentially human constructs. Inheritance disputes, dynastic succession, marriage alliances, honor, shame, governance of kingdoms. Concepts deeply tied to human social evolution on Earth. It's far more likely, far more parsimonious, the simplest explanation that these stories were created by humans for humans, about human concerns, triumphs, failings. And then, crucially, the pervasive lack of evidence beyond a theoretical what if. Just as there's no scientific evidence on Earth for these events in the distant past, there is absolutely no signal or artifact, no verifiable interstellar message, no anomalous material, no extraterrestrial archaeological trace, no verifiable alien presence to suggest these events occurred elsewhere or were transmitted here.
Nothing at all.
Nothing verifiable. It's a hypothesis built solely on the absence of Earth-based evidence, which, while intriguing for speculation, isn't scientifically sound. Absence of evidence isn't evidence of absence, sure, but it certainly doesn't support something extraordinary. It remains untestable speculation. This brings us back to Occam's razor. Among competing hypotheses, the one with fewest assumptions is usually best. The simpler, more plausible, empirically supported explanation, consistent with all available evidence, is that these epics are magnificent products of human imagination, profound oral traditions, perhaps deeply exaggerated historical events, like other myths worldwide. Their narrative power doesn't need unproven external explanations. So while the extraterrestrial hypothesis is highly speculative, currently untestable, one can theorize advanced civilizations existed elsewhere, their stories somehow reached Earth. But to move this from theory to scientific possibility requires extraordinary undesirable evidence. Interstellar artifacts, verifiable signals, direct contact. Evidence currently absent in 2025. It remains an open door in speculative cosmology, theoretical philosophy. An intriguing what-if inspiring sci-fi, not scientific consensus based on data. Outro.
What an incredible journey we've taken today. Through billions of years of Earth's fiery birth, patient evolution, witnessing life's rise and fall, punctuated by cataclysms, all leading to humanity's comparatively fleeting yet incredibly impactful moment on this planet. It's clear that while science provides us with an incredible, detailed, evidence-backed timeline, the Ramayana and Mahabharata offer profound, timeless insights into the human condition, enduring dilemmas, our boundless capacity for imagination and storytelling.
Your question truly highlighted how human curiosity can bridge diverse, seemingly disconnected fields, pushing us to explore beyond the obvious. Whether these epics are interpreted as ancient science fiction, allegories for universal struggles, or even theoretical possibilities spanning galaxies, their enduring power lies not in literal historical accuracy. Instead, it rests in their profound symbolism, ethical teachings, their remarkable ability to serve as multi-layered maps of consciousness for all time. They are not simply records of what was. They are powerful narratives, helping us understand what could be individually in our choices, collectively as societies, navigating existence yesterday, today, and tomorrow.
And that for us is the ultimate deep dive. Thank you and hope to see you in the next episode.